the next presentation, that is the one from Centric. We have Efstathios Katranaras from Sequans, and Efstathios, floor is yours.
Hello, Mario, everyone. Mauro, sorry. Hope you can hear me. You can see my slides.
We can hear you, but we cannot see yet your slides, actually. So.
Okay. Let me share my screen then again. Maybe now.
Yes.
Okay, perfect.
Now, thanks a lot.
So, I'm Efstathios Katranaras from Sequans, and I'm presenting the view of Centric to this workshop. So in Centric, the goal is to enable user-centric 6 networks through AA native interface. The general motivation in Centric comes from the fact that current networks are built to be service-centric. This is an approach that has reduced traffic categories to a small set of KPI profiles that, yes, they reflect the network limitation, but not the real user needs. So current networks are also built bottom-up with one-size-fits-all philosophy, meaning that the protocol stack is built first and then applications are deployed over the stack. However, what is new in communication and recently is that we have a growing diversity of users, a growing diversity of applications, also environments of the general environments of the wireless ecosystem. So for this reason, the Centric project main idea is to, what it proposes and investigates is how to leverage the AI techniques through a top-down modular approach. So as shown in this figure here, it all starts with the user communication needs and also the application-specific requirements. And then we have tailor-made waveforms, transceivers, signaling, protocols, and hardware implementations that are optimized adaptively and on demand within a modular architecture to support these requirements. So this is the main vision and goal of Centric. In terms of consortium partners, just to say that we have the consortium consists of partners with a wide variety of expertise and from different areas within Europe. Okay, so now this is a diagram that gives an overview of the key objectives and challenges that Centric tries to take care of. We have objectives such as developing AI methods for the discovery of waveforms, transceivers, customized lightweight protocols, objectives like introducing end-to-end hardware co-design solutions for transceivers, developing training and monitoring environments, and also validating AI solutions, AI for interface in lab settings. So these objectives and challenges have shown us the areas of need for technical innovation, and Centric technical enablers, or we call them also technical innovation areas, they revolve around these innovation areas. So more specifically, I have a couple of slides here to generally discuss these technical enablers. These include end-to-end learned waveform and modulation, such as waveforms for sub-terahertz and short packet transmission, or user-tailored modulation learning. It also includes AI-empowered MIMO techniques, such as deep learning for multi-user MIMO receivers, learning frameworks for CSI acquisition and MIMO precoder, methods for sensing edit beam operation in millimeter wave. And it also includes the technical enablers include application and service-specific learned protocols, such as for multiple access and for transmission mode selection. The technical enablers also include methods for sustainable and human-friendly radio resource management, considering, for example, the EMF exposure. And this is all applying to caching methods, self-free MIMO, and multi-objective AI methods. Additionally, we have AI computing hardware and real-time optimization, considering. So we're looking into GPU acceleration methods and deep learning algorithms. We're looking into computing platform design based on neuromorphic computing paradigms, among others. It also includes training and monitoring environments for AI models, including guidelines, algorithms, and procedures for the management of AI models, including also calibration algorithms for ray tracing in digital twins via phase-aware optimization. There's an implementation in Siona simulation environment for this. And finally, technical enablers include the investigation on AI suitable testing frameworks and proof of concept with an ongoing implementation of a multi-user MIMO neural receiver in POC. Okay, so in terms of KPIs, what is Centric's view in KPIs and KPIs? Also have a couple of slides for this. Generally, we categorize KPIs in Centric in four groups, four categories. We consider the conventional KPIs, which are used to characterize the performance of our interface, the legacy one. We consider also what we call common AI KPIs that are assessing performance and complexity of AI-based interface techniques. We consider EMF-related KPIs that assess the EMF radiation that is incurred in humans, and also what we call enabler-specific KPIs. These are more tricky, more AI-related intermediate performance KPIs that are relevant to a single Centric enabler and cannot be categorized into something else. Now, in terms of KPIs, often when we discuss about key values, we think about this indirect impact that is obtained from a technical enabler through the use case or the application that we consider. But in Centric, because it's a use case agnostic project, it focuses mostly on fundamental enablers. It's a bit difficult to do this evaluation, this indirect impact evaluation and assessment. So the enablers in Centric, they directly impact sustainability of 6G networks. So we try to see KPIs from that point of view. And we define a couple of KPIs for the three families of sustainability here. So for environmental sustainability, we consider KPIs such as energy efficiency improvements, material efficiency improvements. For economical sustainability, we defined the two KPIs of CAPEX and OPEX reductions. And for societal sustainability, we have the two KPIs of EMF aware networks and regarding user data protection and privacy. Now going into the standardization, which is of course the main topic of the workshop. Generally speaking, in the context of wireless communications, the integration of AI in the air interface is yes, it's a hot topic. It's an emerging area of research and development. So it's a good opportunity for Centric to step here and grow up together with standardization on this area. And that was our plan from our initial plan to follow the most relevant bodies on 6G and specifically on AI design, monitor the ongoing activities, and try to promote impactful findings and proposals. And we set up an iterative procedure, an iterative approach to do that. We initially, first steps of the project, we try to identify which are the suitable SDOs working on the specifications, channels to access them, and we try to monitor ongoing activities and in parallel with the work progress in Centric. And there was here the iterative approach of bringing the knowledge back to the consortium and then aligning our technical developments and planning for contributions of the group according to what is happening in standardization. More specifically, we saw here the SDOs and work groups that we have targeted to follow and that we follow. These include 3GPP, of course, run NSA groups, as well as specific work groups of potential relevance in ETSI, IEEE, and ORAN. So after this, as I mentioned, starting identification within Centric, we have allocated watchers that are monitoring all these groups. And in fact, we also contribute, we have several contributions in RAN groups of 3GPP, which are the most relevant areas on the work that we are doing up to now. And I think we will continue contributing TDocs and solutions there. Speaking of contributions and TDocs, so this is actually to show more specifically what was the short-term impact, or what has been the short-term impact of Centric to the standards. So we have contributed to the general study and development of initial specifications of AI ML techniques in RAN 1. We have contributed to the design of CSI feedback enhancements, such as prediction and compression. We have also evaluation results provided to 3GPP RAN 1. Also on the design of beam prediction, such as ideas about impact of assistance info of beam prediction, or meta learning for beam prediction method, or device agnostic codebook design. And we have also contributions so far to RAN 4 requirements, to aspects related to RAN 4 requirements in topics such as AI/ML model monitoring, interoperability and testability, and discussion on the use cases there. But I think if we want to consider what can be the long-term impact of Centric to related standardization, which is more important for the future, I think we need to consider the various gaps and key areas for improvements. And as I said, since Centric started more or less together with the beginning of this kind of studies for potential specification in communications, such as the AI/ML study in 3GPP RAN, our understanding on the gaps has been running in parallel to these efforts. So generally speaking, while AI has great potential to optimize and improve the performance of the air interface, there are notable significant gaps and shortcomings identified in standards that were needed and still need to be addressed for full integration of the topic. And then we see our work as adding stepping stones into this large area. So first, there had been this lack of having a general framework for AI for interface, including aspects of how to save, how to securely access data, and how to share for AI training, also across operators and vendors. What should be the AI model lifecycle management and the update? So, the life cycle of AI models, such as the training, the testing, the deployment, the retraining, was not yet, or is not yet fully integrated into the cellular communication standards. And there is also a gap in defining how frequently AI models should be updated, how performance should be evaluated over time, and how these models should adapt to changing network conditions. Second, there is this issue of integrating with existing protocols. So AI solutions must integrate with legacy cellular technologies that do not rely on AI for decision making. So you can actually have AI-driven and non-AI-driven systems in hybrid deployments. And standards are needed to ensure smooth coexistence between those, especially during the transition phase from 5G to 6G. In addition, current standards do not sufficiently address yet how AI models can be integrated into the existing communication protocols like RRC, MAC, and file layers, which leads to implementation complexity. And some steps are taken towards this direction lately. The third aspect is generally about this complexity for AI-driven framework, how it can be kept at low levels without having serious degradation in performance. And this is also a very important topic to address if we want real AI-based implementation to materialize in 6G networks. The fourth topic is about having a uniform framework for testing and validation of AI models. So there is a lack of standardized metrics to evaluate the performance of AI models in their interface. And the current benchmarks that we have often do not account for real-world variables like user mobility, network heterogeneity, also environmental factors that can significantly impact the AI model performance. Also, while AI-driven systems are tested in simulations, there is no uniform standard for testbed environments. So existing simulations often differ significantly from the real-world network deployments and results. And this limits seriously the generalizability of test results. So Centric, as you can see, our contributions mentioned in previous slides is touching topics on all those four aspects that were just mentioned. But of course, there are more key areas that need addressing. Although they're deemed out of the scope of Centric, it's good to mention them. So, for example, we have aspects such as we need to define standards to meet acceptable latency, computational complexity, processing, or even power consumption of AI models in order to meet future communication requirements. Because you have AI models, but especially these deep learning-based approaches can be very, very computationally and power intensive, and can introduce also big latency, which is very, very problematic if you consider the time-sensitive functions of the air interface, such as handover decisions or scheduling decisions. Another key area is cross-layer AI optimization. AI can potentially optimize across different layers of the air interface stack, the PHY, the MAC, the RLC, but there are a few standards that facilitate this type of cross-layer optimization. Mostly they're focusing on individual layers without addressing the integration challenges across them. And also another key area that we thought of is this AI model interoperability across networks. So yes, you may have AI solutions that may work well in single vendor or operator control environment, but they can face challenges when deployed in multi-vendor environments because you have a lot of proprietary AI algorithms. So yeah, we need to think of standards that promote open interfaces and interoperability between AI-driven air interfaces, and this is generally lacking. And of course, there are several possible more gaps that are not included here that we still need to identify as work on this topic progresses more. To close, I wanted to give some views or some ideas for future collaboration. So in terms of areas for collaboration with Hexa-X-II and other projects, because I saw them also in the previous presentations, there are many projects work on this direction, maybe not so much on air interface, but in other aspects. But it will be good to sit all together somehow and align our views on aspects, on AI ML frameworks, for example, or on what are the different SDOs that each one is following and contributing. Also, it will be interesting to see if we can gain from each other. For example, Hexa-X-II is working on architectural work. Centric is focusing on algorithmic work. Other projects are also focusing on architectural work. So it would be good to see if we can combine this algorithmic work from Centric with the architectural ideas that is being developed in these projects. And on the question that was about harmonization and maximum impact, how maybe Hexa-X-II can organize that, or how all can together work on that. I think one important topic is to try and harmonize the understanding of current status, AML progress in 3GPP or in other groups. Of course, there is this SNS pre-standards group, but I think this is a bit more generic, tackling all aspects together. So maybe we can organize a workshop specifically on that. on AI/ML, also on identifying gaps for 6G. We can have complementing views from different related projects to complement what I discussed earlier in the previous slide, and also highlight and coordinate for upcoming opportunities to contribute in standard study work design from different projects. So yeah, that was from my side today.
Okay, thanks a lot, Efstathios. I don't see questions for you on the chat, so once again, thanks a lot for your presentation. We are exactly at 5, so we may go to the next session that is on security, in particular secure service development and smart security. And we have one presentation that is from confidential 6G project, and Vera Stavroulaki from Wings will give us the presentation. So Vera, I can see you are starting the sharing.